Okay, our learning target for this particular type of problem and for today is that I can use differentiation to determine optimization. If you remember from pre-cal, optimization is where you're trying to find a minimum or a maximum value associated with a real world situation. So we're given this problem here, and you can see the problem, so I'm not going to read the whole problem to you, but I am going to annotate the important pieces. So we're making a poster, and the poster has a 72-inch squared photo surrounded by a border, and the border is 4 inches at the top and the bottom, and the border is 2 inches on both sides. I'm going to do that in a different color. Okay, we are being asked to determine what the overall dimensions of the poster should be to use the least amount of paper. So we're going to want to find a minimum. The way that I would start this particular problem is I would draw a picture. So I have a poster, and my poster has a photo in it with a 4-inch border at the top and bottom and a 2-inch border at each side. I have a length and a width of the poster, and I know that this inside area is 72 inches squared because the photo is 72 inches squared. So I know that I'm going to have one equation. 72 is equal to length times width. And then I need an area equation for the entire poster. The entire poster, then, the area would equal the length plus 8, 4 for the border for the top and 4 for the border for the bottom, and W plus 4, 2 on each side of the W. So my next step would be to solve the area equation 72 equals LW for either length or width so that I can substitute into my first equation or my second equation. So I'm going to go ahead and divide both sides by W. And when I do that, I have 72W equals L. So I'm going to replace my L with 72W with substitution. Area equals 72 over W plus 8 times W plus 4. I'm going to simplify that with multiplication. So my area equals 72 plus 288 over W plus 8W plus 32. Now I need a minimum, and I know that in order to find a minimum, I take a derivative. So I'm going to go ahead and take the derivative of my equation, my area equation, and A prime equals the derivative of 72 is 0, so I'm going to ignore that. The derivative of 288 over W, I'm going to do that over here on the side. I'm going to rewrite that as 288W to the negative 1, giving me a derivative then of negative 288 over W squared. And if you didn't follow that, you can get it from a quotient rule. So negative 288 over W squared, and the derivative of 8W, of course, plus 8. Now I do know that when I'm using the derivative to find a min or a max, I do need the critical point, and the critical point is, of course, where the first derivative equals 0. So I have 8 equals 288 over W squared. I'm going to cross multiply with that, giving me 8W squared equals 288. Of course, we're going to divide by 8. W squared equals 36, and W equals 6. Positive 6 only because negative 6 would not be applicable in the problem. And then I look here, they want the dimensions for the entire poster, So my photograph has a width of 6. If I add 2 to both sides, my width of my poster then is 10 inches. My length happens to be 72 over W. Well, 72 divided by 6 is 12. So my length is going to be 12 plus 8 for the border, 20 inches.